In this lesson, we are going to learn how to use the dot product. The dot product between two vectors is an operation that produces an output. And the output of the dot product of two vectors is not a vector, it's a number. And we are going to learn what it means, this number. We are going to solve these 10 problems. Stop the video, see the problems, try to do it by yourself, and I'll see you soon. Before doing the problem, we are going to review the definition of the dot products. Given two vectors A and B, how we define A have a magnitude and have a direction. This is the direction of A running in this direction. This is the direction of B running in this direction. So once that we have two vectors, we have two magnitudes and two directions. What we mean by the dot product? We mean to obtain a number that is obtained by doing the following operation. Find the magnitude of A. The dot product of A dot B is find the magnitude of A. Find the magnitude of B. Find the angle between A and B, and find the cosine of the angle. Multiply the magnitude of A by the magnitude of B by the cosine of the angle, and this is the dot product of two vectors. When the angle is 90 degrees, cosine of 90 is 0, so the dot product is 0. When the angle is smaller than 90 degrees, cosine of an angle smaller than 90 degrees is positive, so the magnitude of A is always positive, the magnitude of B is always positive. So as a result, for an angle smaller than 90 degrees, this dot product, the product of these three terms, will be positive. If the angle is bigger than 90 degrees, cosine of something bigger, of an angle bigger than 90 degrees, is negative. So the dot product is negative. So how we can interpret this? If you rearrange A dot B in this way, you express A dot B cosine of theta in the form magnitude of A cosine of theta multiplied by B. What it means geometrically, this operation? This operation means this is the magnitude of A, the length of A. A cosine of theta is this part. So you multiply this length that is smaller than this length. And this length is magnitude of A cosine of theta. You multiply by the magnitude of B. The other possibility is to do it in a different order. You can write A dot B like magnitude of A multiplied by magnitude of V cosine of theta. And now you consider this term. What is magnitude of V cosine of theta? Magnitude of V is all this length. Cosine of the angle theta, cosine of this angle theta, is to project perpendicular to A the length of B. So magnitude of V cosine of theta is all this length. All this length is magnitude of V cosine of theta. So you multiply this length by the magnitude of A. The magnitude of A by this length, the magnitude of V cosine of theta, is the dot product. The two things are equivalent. So when we have two vectors A and V, we have a system of a Cartesian system where I have the components of the vector, and the components of the vector are A1, AX, and AY. And what is AX? AX is the magnitude of A by cosine of theta. What is AY? AY is the magnitude of A by sine of theta. Okay, can we express the dot product in a different way? Yes, this is the useful ways to express the dot product. We have said that A dot V is the magnitude of A by the magnitude of V by the cosine of the angle that they form. But the cosine of the angle that they form is theta, and theta is theta 2 minus theta 1. This is theta. This is this angle. So is multiplied by the cosine of theta, which is theta 2 minus theta 1. Okay, if you remember how to write cosine of theta 2 and theta 2 minus theta 1 in terms of cosine and sines, from pre-calculus, you will remember that cosine of theta 2 minus theta 1 is cosine theta 2 multiplied by cosine theta 1 plus sine theta 2 multiplied by sine theta 1. Okay, now let's go to rearrange this equation and write it in a way that we can recognize terms. If I write it like this, magnitude of A cosine of theta 2 multiplied by magnitude of V cosine of theta 1 plus magnitude of A sine of theta 2 multiplied by magnitude of V sine of theta 1. I can recognize this like AX. I can recognize this like VX. This is the X component, the magnitude of V cosine of theta 1, the magnitude of V cosine of theta 1, see here, the magnitude of V, this length, cosine of theta 1 is Vx. And this is Vy, which is the magnitude of V sine of theta 1. Perfect. So it would be AX Bx plus AY By. As a conclusion, I have a useful formula to apply in all the equations. That is that A dot V is the magnitude of A by the magnitude of V by the cosine of the angle, but is also AX Vx plus AY By. Then the formula that I will use in problems is that the cosine of the angle that they made, the two vectors made, is AX Vx plus AY By divided by the magnitude of A multiplied by the magnitude of V. And this is the equation that we will use in many of the problems that are here. Next equation that we are going to use is the projection of a vector onto another vector. So let's say that you have U, the vector U, and you have the vector V. What it means the projection of U onto B? It means the following thing. You make a perpendicular line to V, to project onto V. So this angle is 90 degrees. And the length of U, the magnitude of U, is projected on the direction of B. And this is the magnitude of U projected on the direction of B. This amount is the magnitude of U projected on the direction of B. And what is this magnitude? This angle is theta. The magnitude that is projected is U cosine of alpha. So this angle is alpha. The magnitude that is projected, this length, is the magnitude of U by cosine of alpha. So the magnitude of U multiplied by cosine of alpha is this length. But the projection of u onto b means a vector. Which vector? This vector. The vector that have the length of the projected vector u onto b and the direction of the vector v. So it has the direction of the unitary vector v. As a conclusion, this is the unitary vector v, have unit 1. As a conclusion, the projection of u onto b is the magnitude of u cosine of alpha, that is the amount of length that stay on the direction of b in the direction of p multiplied by the direction by the unitary vector v. So the projection of u onto p is a vector, is the vector whose length is u cosine of alpha, whose direction is the unitary vector v. From this equation we can manipulate, we can massage the equation to write it in a different and more complicated form. But to write it here is perfect also. So most of the textbooks, they play with this equation to do the following thing. U cosine of alpha is the same that u dot v divided by the magnitude of v, because u dot v is magnitude of u by magnitude of v multiplied by cosine of alpha. If I correct u dot v dividing by the magnitude of v, I have this term. Magnitude of u cosine of alpha is the same that u dot v divided by the magnitude v, multiplied by the unitary vector v. Perfect. So this is the vector that represents the projection of u onto the direction of v. Now we can still going on a little bit more and write the unitary vector v is the vector v divided by the magnitude of v. Now we can put the magnitude of v here, so it will appear v squared. So it will be u dot v divided by the magnitude of v squared vector v. And now it's not the unitary vector, now it's the vector v. So we can use this equation, or you can use this equation if you want. It will be the same equation. So in problems, they will ask you to use these equations. Probably this or this. We will do it in both ways to see that it will work. Let's go now to do the problems. The first problem that we are going to solve is to find the dot product between two vectors. We are going to find a number. The two vectors are u, 3, 4. So it's the vector that goes from the origin to the point 3, 4. And the vector v is the vector minus 1, 5. So it's the vector that goes from the origin to the point minus 1, 5. How we will do the dot product? The dot product of two vectors, u and v, will be 3, 4 dot minus 1, 5. And this will be a number. What it will be the number? Multiply components by components and sum it. Multiply the 3 by minus 1 and add 4 multiplied by 5, and you will obtain a number. And this is the dot product. Then we will do the operation. The dot product will be 3 multiplied by minus 1 plus 4 multiplied by 5. The number will be positive, so it will be 70. The dot product has 3 possibilities for the number. The number may be positive, the number may be 0, or the number could be negative. What it means, a positive number like in this case? It means that the projection of u through v happens in the direction of b. So if you have u and you have v, let's say u, and v, u, and v, the vector u and v, the projection of u through v happen to be in the direction of v. The direction of v is running in this direction. So the dot product is positive when the projection of u is on the direction of b. And the dot product is 0 when the projection of u in the direction of b never happened. There is no projection. And the dot product is negative when the projection of u onto b is negative. It happened to be in the negative direction of b. So this will produce u dot v negative. This will produce u dot v positive. And this will produce u dot v 0. And the problem is solved. Now we again solve another problem. Find the dot product of the vector u, 6 minus 4, so it's the vector that ran from the origin to the point 6 minus 4, dot product, the vector v equal minus 3, 2. You can represent the two vectors and you can realize if the dot product will be positive or negative, or 0 if they are perpendicular. So how we will do the dot product? U dot b will be 6 multiplied by minus 3 plus minus 4 multiplied by 2. Then we will have u dot b. And u dot b will be this multiplication. 6 multiplied by minus 3 plus minus 4 multiplied by 2. If we do the multiplication, we will find a number, and the number is minus 26. What it means that the dot product is negative? It means that u will be in some direction, but v have to be in this direction in a way that v is in the negative direction of u. U is running in this direction. So v is in the opposite direction. So the angle is bigger than 90 degrees. So the dot product is minus 26. Let's go to solve the next problem. On this problem we have two vectors, the vector u and the vector v. The vector u is the vector that goes from the origin to the point 3, 4. So it is 3i plus 4j. And the vector v is the vector that goes from the origin to the point minus 8, 6. So it's the vector minus 8i plus 6j. And we want to find the angle between the two vectors. To find the angle between the two vectors, we will use the equation that we have deduced at the beginning of the lesson. And the equation that we have deduced at the beginning of the equation is cosine of theta is the dot product of the two vectors divided by the magnitude of the first multiplied by the magnitude of the second. If we plug in data, the data for u dot v is that u is 3 multiplied by minus 8 plus 4 multiplied by 6 divided by the magnitude of 3, 4. The magnitude of 3, 4 is a square root of 3 squared plus 4 squared. The magnitude of v is a square root of minus 8 squared plus 6 squared. If we do the algebra, we will find that the dot product is 3 multiplied by minus 8 plus 4 multiplied by 6 divided by the magnitude of u, square root of 9 plus 16, multiply by the square root of b. If you do the multiplication, the dot product will be 0. The numerator will be 0, and 0 divided by something is always 0. So the dot product will be 0. What it means that the dot product is 0? It means that the two vectors are perpendicular. Then the two vectors that we are considering have an angle 90 degrees. To be orthogonal, to be perpendicular, or to be normal to a plane is the same words, or we use the same word, orthogonal, perpendicular, or normal to the surface. Okay, perpendicular to a surface. These are three words. Let's go to the next problem. This problem say use a calculator to approximate the angle between two vectors. The vectors are 3, 1 and 2, minus 2, 4. Well, if we found the cosine of the angle, using our equation cosine of theta equal u dot v divided by the magnitude of u multiplied by the magnitude of v, we will obtain cosine of theta. And from cosine of theta equal, if you do the number, you will find minus 1 divided by square root of 50. And if you use your calculator, you can find that theta will be arc cosine of minus 1 divided by square root of 50. And this will be equal, use your calculator, should be, if cosine of theta is negative, should be an angle bigger than 90 degrees. So the two vectors, they do like this without writing u will do like this, and the angle will be a little bit bigger than 90 degrees because the dot product here is a negative number. Okay, and this is the problem. So using your calculator, the angle will be 98.1 degree. So the angle is 98.1 degree, which is bigger than 90 degree. If they were 90 degree, the cosine of 90 will be 0, and they were perpendicular, and u dot b will be 0. Let's go to the next problem. Okay. Problem 5 say find the projection of u onto b. The vector u is this vector, 6, 7. The vector v is 1, 4, is this vector. And what it says, find the vector that lies on the direction of b. The direction of b is this direction. The direction of v is this direction. Okay, on this direction. So you have to project the vector u perpendicular to the direction. Let's go to project it, 90 degree here, 90 degree here. So the projection of u onto the direction of b is this vector. This is the vector that they are asking me to find. The vector that goes from here to here. Wow, who is this vector? And this vector is u dot b divided by the magnitude of v squared multiplied by b. Let's go to plug in numbers and to find who is v. U dot v will be u dot b will be 6, 7, 6, 7 dot v 1, 4 divided by the magnitude of v squared. What is the magnitude of v squared? Is the magnitude of v is square root of 1 squared plus 4 squared. But it say the magnitude of v squared, so it's 1 squared plus 4 squared, in multiplied by v. So this term in brackets, or this term in bracket, is a number. Is how many times of v is the projection. So the projection looks that is v is here, you see? So the projection looks bigger than v. It's maybe 2 times v. Let's go to do it to see if it's 2 times v. Let's go to do the dot product. If we do the dot product, 6 by 7, 6, 7 multiplied by 1, 4, it's 6 multiplied by 1 plus 7 multiplied by 1 divided by the square root of 16 plus 1 square. 16 plus 1 square is 17. So 28 plus 16 is 34. Divided by 17, this is 2. So 2 times v. Oh, the projection is 2 times v. So the projection of the vector u onto v that we have calculated as u dot v divided by the magnitude of v squared multiplied by the vector v. This was 2 times v, but v is the vector 1, 4. So it's 2 times 1, 4. Or 2 times 1i plus 4j. Or 2i plus 8j. Or 2, 8. So this is the vector that represents the projection of u onto v. And the problem is solved. Let me write the 8 correctly. 8. This is an 8. Okay. 8 because 2 by 4 is 8. Now this problem is the same like the one that we did before, is find the projection of u onto v. We use the same equation that we have deduced at the beginning of the lesson. Is u dot v divided by the magnitude of v squared multiplied, this is a number, multiplied by v. This is the vector that is the projection of u onto v. Plugging numbers, it will be, this number will be 0, so 0 times v, so it means that there is no projection. The vector is the vector 0. If there is no projection, it means that u and v are perpendicular. So you can draw this vector and you can realize that are perpendicular. Let's go to the next problem. The next problem is again this, to practice the same equation. So the problem is the same. Given u and v, I have represent u and v. This is u, 2, 3, and this is v, 5, 1. It says first, find the projection of u onto v. So find the red vector, this vector. Find this vector. And the second thing is find the projection of u onto v, and the vector component of u ortho, and find this vector, the vector that is perpendicular. This vector is the vector that we have to find also. So there are 2 vectors that we have to find, these vectors and this vector. Okay, to find the projection of u onto v, we apply the same equation, u dot v divided by the magnitude of v squared multiplied by v. It's clear that the projection of u onto the direction of v is this vector that is maybe half of v. Maybe. let's go to do the calculation. The calculations say that the vectors W, that is the projection of U onto V. So he's calling this vector W. The vector W is obtained by using our equation U dot V divided by V squared, 2 by 5, plus 3 by 1 is the dot product of U and V, divided by the square root by magnitude of V squared. So it's 1/2 of V. Oh, so the vector projection is half of the vector V. So who is V? V is 5i plus 1j. And what is 1/2 of 5i plus 1j? 1/2 of 5i plus 5 divided by 2i plus 1/2 of j. And this is the vector projection of U onto V, or what we call W1. Now we have to find W2, that is the perpendicular vector. How we will find? We know that W1 plus W, let's go to call it perpendicular instead of 2, is equal U. Seeing the picture, W1 plus W perpendicular is U. So we found W perpendicular. W perpendicular is U minus W1. Who is U? U is the vector 2i plus 3j. 2i plus 3j. Who is W1? The projection of U onto V is 5/2 I plus 1/2 j. And what is the difference in between the two vectors? Is 2 minus 5/2, or 4/2 minus 5/2 minus 1/2 I. Oh, we do the j component. The j component is 3 minus 1/2. 3 is 6/2. 6/2 minus 1/2 is 5/2. So it's plus 5/2 in the j direction. And this is the result for the vector that is perpendicular. This vector, this one. And the problem is solved. If you on this problem, it says that you have on an inclined plane a track, and the track, the weight of the track, let's go to think on the weight like a force in newtons, so it's 48,000 newtons. So this is the track, this is the 48,000 newtons, and the track is going to move in the direction of S. So what it's asking is, how much of the 48,000 exists on the direction of S? Well, you know how to do it, because we have to find the projection of the force F, this force, onto the direction of S. So the vector S, let's go to find the vector S. The vector S is made of two vectors. One vector in the minus j direction, this vector, and the vector S have the magnitude 1. So this amount is 1 cosine of theta, and 1 cosine of 10, because this is 10, and because this is also 10 here. So this is 10, and this is 10 also. So it's 1 cosine of 10 in the minus I direction, plus 1 cosine, plus 1 sine of 10, 1 sine of 10 in the minus j direction. So this is the vector S. The vector S is this vector. It goes parallel to the inclined plane. And what is the projection of S onto the projection of F onto the direction of S. Is F scalar S. This is a number multiplied by the vector, unitary vector S. What is F? F is minus 4,800 J. What is the unitary vector S? Is the one that we found. And what is the dot product of this? What is this part of here? This part you multiply scalar J scalar I 0, J scalar J is 1. Then the dot product will be minus is plus, it will be 4,800 sine of 10 in the direction of the vector S. So 4,800 sine of 10 in the direction of the vector S. Who is the vector S? The vector S is minus cosine of 10 minus sine of 10. Is a unitary vector. So the force that exists on the direction of S is this amount of force. Or in other words, is the force, let's go to write it, is the force 4,800 sine of 10 minus cosine of 10i minus 4,800 sine square of 10 in the j direction. So this is the amount of force that exists on the s direction. And this is the answer. And what is what is the magnitude of this force? Because it's asking about the magnitude. Find the force recurring. Okay, what is the magnitude of this force? And the magnitude of this force, let's go to see it here, that is easy to hear, is 4,800 sine of 10. This is the magnitude of the force, because the magnitude of S is 1. So this is the magnitude of the force that exists in the S direction. And of course, that this is equal to 4,800 cosine of 80, because sine of 10 is the same that cosine of 80. So what we have done, that we could have done at the beginning, this is the inclined plane, this is 10, this is the track, this is the weight, 48,000. This angle, if you do it like this angle is here, the 10 is here, so the 80 is here, 80. So you have the weight, 48,000, you have 10 degrees here and 80 degrees here, because this is 90 degrees. So it's clear that 4,800 multiplied by cosine of 80 will project this vector into the S direction. So this will be the amount of force that exists. 4,800 cosine of 80 will be the amount of force, or 48,000 cosine of 80 will be the amount of force that exists in the S direction. Of course, you need to apply a force in this direction to make sure that the track will not slip down to the inclined plane. So this is the problem. Okay, in this problem they say that we have a car and the car is down with a force that makes 25 degrees with the horizontal. So it's pulling with this force during the distance 2 kilometers from A to B. Let's go to put here from A to B. This is the observer, so the observer see the objects at some position, and later on he see the object at the further position, and the displacement is here. Here is the displacement. The displacement is 2 kilometers. So this is the displacement from A to B. From A to B, the displacement is 2 kilometers, and the force and the work is the force in the direction of the displacement. So if F cosine of the angle is the force that exists in the direction of the displacement, this is the force. The force on the direction of the displacement is F cosine of 25. So this is the force F cosine of 25. This is F magnitude of F cosine of 25. So the work is the force in the direction of the displacement multiplied by the displacement. The displacement can be written like delta S or delta R. Or in other words, is the dot product of F scalar delta R. So there are two ways of doing this problem. The first way is to do it in vector form. In vector form, we will write that the force is, this force is made of two forces. One is going in the x direction, F cosine of 25 is going in the I direction, and F sine of 25 is going in the j direction. So the force is 1,600 cosine of 25 in the I direction plus 1,600 sine of 25 in the j direction. And the displacement is going the x direction. So the displacement is 2 kilometers in the I direction. So the work is the force dot the displacement. It's the dot product because it projects the force onto the direction of the displacement. So there are two ways of doing. One is using the definition of the dot product, the magnitude of the first by the magnitude of the second by the cosine of the angle that makes the force with the displacement. So you plug in numbers and it would be 1,600 by 2 by cosine of 25. And this will give you the work in joules. The other way to do it is to use the dot product using the vectors. So F dot delta R, plugging F dot delta R, and doing the dot product, you will arrive to the same result because I dot I is 1 and J dot I is 0. So the work will be 1,600 cosine of 25 by 2. I dot I is 1. And this is the same result that this one, and the work is measured on joules. And the problem is solved. Okay, let's go to the next. The last question, it says, what is known about an angle between two vectors if the dot product is negative? If the dot product is negative, because magnitude of A dot V is magnitude of A positive divided by magnitude of V positive by cosine of the angle, could be C, cosine of the angle could be 0, positive or negative. If this is 0, if the dot product is 0, it's because the angle is 90 degrees. If the dot product is negative, it's because the angle is between greater than 90, smaller than 180. So the geometry of the situation is like this. This is A, and this is B. And the angle between them is bigger than 90 degrees and smaller than 180. So the angle is always the angle between the two vectors. So what is happening when it's negative? That the angle is an obtuse angle. Well, that's all about the dot products. We will continue with a new lesson. The next problem say, what is known about an angle between two vectors if their dot product is negative? Well, the dot product of two vectors are defined like the magnitude of the first by the magnitude of the second by the cosine of the angle. So the dot product can be positive, can be negative, can be zero. When is positive? It's positive when there is projection on the direction of the vector A. So if this is V and this one is A, the dot product will be positive because the cosine of the angle is an angle that is less than 90 degrees, and the cosine of an angle that is less than 90 degrees is positive. So the dot product will be the magnitude of A positive, the magnitude of V positive, cosine of 10 or cosine of 20 positive. So the dot product is positive. When the angle is bigger than 90 degrees, 100 or 110 or 120, the cosine is negative. So the dot product is the magnitude of A positive, the magnitude of V positive, and the cosine of the angle bigger than 90 degrees, between 90 and 180, negative. So the dot product is negative. So what is known about an angle between two vectors that if the dot product is negative? If the dot product is negative, is because the two vectors are perpendicular, because cosine of 90 is 0. So if A dot V is equal 0, it's not because the magnitude of A is 0, or not because the magnitude of V is 0. It's because cosine of theta is 0. So cosine of theta 0 means theta equal pi divided by 2. So the two vectors are perpendiculars.